Welcome back to VTU e-Shikshana program on computer aided engineering drawing. We are working on module 3, that is development of surfaces along with sections of solids. We have learned briefly what exactly sections are solids and also worked out number of problems on development of surfaces. Now we are working on funnels, that is one of the part in the syllabus or topic in the syllabus. Now I have the different funnel types, simple balloon types. There will be truncation here. Afterwards, I will deal with that. Now, let me take these 4 figures and discuss. The funnel is a part of cone with the big diameter is top diameter is 80 mm and 30 mm is the small end. And this is the cylinder type, okay, of 70 mm height and 30 mm. Here it is again part of cone, that is frustum of cone. This is also frustum of cone with 30 and 80, same thing. And here I have again frustum of cone with 30 base end and the 15 the top end or the small end. So here I have same type of frustum of cone, but it is truncated with the big end reference. So with one right top corner we have section plane. Assume that section plane is cutting the frustum of cone passing through this right extreme point, and then at an angle of 15 degrees, okay, or any suitable angle given. Now here also same thing, but here there is a cylinder part, that is simply cylinder, and this is part of cone, and there may be the truncation here. The next level I will deal with that. Now let me discuss this particular type of figure funnels. Now I will take this type and also this type, because these two are same. Again, these two are same. Next, the difference is the cone. Whenever you want to draw development of complete cone, you are supposed to draw the base circle and then divide that into n equal parts, because there will be some truncation. Second type. If there is no truncation like this, there is no divisions. Okay. Now let me in general take this and do it. That is for the second type. First type we have only this. This is frustum of cone. Assume that I have taken 80 and 30. This is 80 and 30, then projected up and got V. Now the value of imaginary generator we have to take and then calculate theta. See, the actual development is this. This is theta. And after calculating theta, theta equal to R by L multiplied by 360. After that, you take this L1 and draw. Then required development of this particular part is this. Okay. So this is L1, very simple procedure. This is L. Theta is calculated with this. This is how you draw. This we have done it. What exactly the procedure to be followed in this particular type of funnels? You need not have to draw a complete circle. Now you see I have drawn the semicircle, taking this as the diameter and divide that into 4 parts. Total 8 parts. Okay. Now let me name this as 1 A, B, C, D, E, F, G, H, assuming that this is complete circle. You can draw even for complete circle, that depends on space availability. Then project the same onto the diameter line. Sorry, this you need not divide this into n equal parts, because this is only the frustum. Just extend this, there you have to do it. Okay. Now extend this and calculate this. measure this one. See that the extended line should coincide with single point. Okay, now this is L1. Okay, L1. Same procedure you follow. So I repeat, you draw an arc with L equal to radius. Conveniently you manage the space, the horizontal, vertical, whatever, and then fix theta. After calculating theta, L you know, R you know 40, and then 360, you get this. See, we get around 161 or so for this particular values. Now take L1 and draw. So this is the development of part A. Let me say part A, part B. So this is the development of part A. If you fold it like this, if you remove this and fold it, then you get this one. So this is how you get frustum of cone. Okay. So this is the development, you get it, and then you remove this portion and then fold and join one with one or A with A, whatever, like this, and then you get this type. So this is the way you work for the part A, whether it is figure 2 or figure 1, same procedure. Okay. What about case 2? Case 2 is, part B is again very simple. I will take this and work out. See, this is a rectangular shape paper and I will fold it. So definitely you get cylinder, very simple. So the development of the cylinder equal to a rectangle is the rectangle with height equal to height of the cylinder. This length, total length equal to perimeter, 2 pi r or pi d. This is length. Now this is very simple. So you take parallel method, simple, extend it and then start with a line. You calculate pi d with 30 mm diameter. Okay, assume that this is the, okay, fine. So this is pi d, that is totally L equal to pi d. Now this is the development of part A. This is development of part B. So you can clearly write development of part B, development of part A. So that's all. Suppose that you have truncation here. Instead of regular cylinder, you have truncation. So this is how you get. After you cut this portion, it may be like this or like this. In this case, I can have the truncation in this fashion. So some angle, so 45 degree or 30 degree, whatever the requirement, accordingly one has to have. For that you need the circle definitely and the respective intersection of the same with the generators. Otherwise you can have semicircle as I did like this. Here you don't need, but the reference is this. Here divide this into helical part 4. That becomes 8. This is 1, 2, 3, 4, 5, 6, 7, 8. Then draw lines. So wherever this intersects, this particular section plane, imaginary section plane intersects the points, you identify. This as A, B, C, D, E, F, G, H. Then divide this into 8 equal parts with suitable means. Okay, so you can have parallel method or whatever. 1, 2, 3, 4, 5, 6, 7, 8. Now project all these points. So here is the starting point. because here the section plane starts 1, 2, 3, 4, 5, 6, 7, 8, 9. Now draw smooth curve. You get the development. So this is development of part B. Part A, part B. So simple one is just cylinder. Here truncated cylinder. So here is the development with a particular given angle. Suppose that if I take the section plane passing through the right bottom point of the cylinder and inclined at some angle. Now if you open it, you will get like this. So for this you have to go for number of imaginary generators, there only you get the profile. So that is what I got, and then got this. So this is, it can be like this or like this. So in this case it's like this. So you have this one. Now I have first type, I did independently, say, and then fix it, join these two. Normally it is sheet metal type, soldering, or some other method is used to do it. Normally it is soldering. So this is how you get the funnel, type 1 and type 2. Okay, so the truncation may be either direction, this direction or this direction, that depends. Okay, so this is how you get the part 1. Now let me take figure 2. So we have the second figure, we have frustum of cone and again one more frustum of cone. This is of smaller dimension and this is little bit lengthier, this is smaller, this is 50 and this is 70. So you will get two segments here. One is again part A and part B. Part A already we know how to do it. Okay, so the part B, again frustum of cone. What happens is, in this type of problems you need little bit more space below this, because you extend it and then try to understand the logic behind calculating theta. This is L and this is L1. So you don't need the circle to be drawn, just you can calculate, but for clarity in computer it's better to draw, okay, so that you get exact dimension. Now how to do it? Suppose that if you calculate theta 2, if I say this is part A, theta of B, part B is R by L multiplied by 360. So you will get some value around 200 and this one is 30, and if you calculate you will get some value, okay, so around 44 degrees or something like that. Okay. Now that all depends on the values you have. So after getting this theta B, draw this. In computer you divide this into 8 equal parts by array if the truncation is there. If no truncation, no division, simply you draw this segment. This value is theta B. This is L for this particular L of B, L of B1, to avoid confusion. Here also we use L. Okay. Now just draw an arc by taking L1, L1, LB of 1. Then this will be the dimension. Now I have this particular segment. Assume that I have the model and I am going to cut at one generator. I will get this particular one. I fold it now. So I will get this folded one will be like this. Okay, this is the development and this is the what the one which is fixed. Okay, with the generator, one of the generator. Now this is the part 1, same type, and part 2. Now I will just give the explanation. So this is part 1 development, this portion is to be removed and you get the what is called this one. Okay, this one. So this is first part assembled and fixed, and this is second part fixed. Okay, so if I connect both like this, like previous one, I'll do like this. So you can, truncation is there, and also there is no truncation with respect to the cross section. It is only tapering, that is frenulum of cone, again frenulum of cone, both are fixed. This is the case. Next, if I do truncation here also, what exactly the impact or the changes? See, assume that I will take from this and remove that portion, and the left one is this. Okay, these is to be removed. What do we do? You have to divide this into n equal parts. For that you need here the divisions. Whenever there is truncation, definitely you need this to be divided, and if you do like this, you must be very careful. Join this V with the points which are projected onto the diameter line. What happens? Sometimes in hurry, people join from this point only to V. It is wrong. Very small variation is there, still you never get the object required. So be careful if you do, otherwise you draw a circle and then regularly you keep the space sufficient and then do it. Otherwise, if you do like this, you must be very careful. Don't join 1, 2, 3, 4 here up to V. You project onto the diameter line, then draw like this. Okay. So this is how you have to do it. Now required part is here, is this. Required part B, this one. Same thing I will utilize. So I divide this into n equal parts. Okay, 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, assume that I have done these 7 parts. Now this is, you can call A, B, C, D, or 1, 2, 3, 5, 6, 7, 8, 9, 1. Now after doing this job, project these points onto the true length line. You never get true length on these lines. You have to project. You know the procedure of drawing a truncated thing. Whenever you get this one, you project all these points onto the true length line. Okay, this is say A, B, C, D, E, F, G, H. Now dash, B dash, C dash, this is axis, D dash, E dash, F dash, H dash, this is V. 1, 2, 3, 4, 5, 6, 7, 8. So all these points from V must be taken from this and then mark on it. Same way here also you have to do it. Okay. So whenever you want to take from A1, 2, 3, 4, 5, 6, 7, 8, if you want to take from for the generator V1, you have to take this point, then this, like that. Then you try to draw arcs. For example, I want to take for 1, that is the farthest point from V, I draw one arc. Then second, third, fourth, fifth, last one. Now keep these points ready. Okay, like this. Then you get the curve like this. Okay. So nearer to V, we have the peak here. So other way around is also true. If you take from this, then the thing is you will get the other pattern. So here is the pattern for this one. See, this is the pattern. I have removed it from this and got the profile. Yes, this is the profile. This is the one which I removed. This portion to be removed. This is to be retained. Okay. So this is the development. Now I will remove it and then fold it. I will get the truncated one. So this is actually frenulum of cone, again truncated. So this is how you get the development of figure 1, part A, part B, part A, then total without any this one, you get this. Now for figure 2, this one same thing is the development, and this one I explained you how to get it. So this is how you get this part is the development for the second part. Okay. So this may be a little more height. Okay, so here if I am correct, you will get like this. This is the point. Yeah, these are the points to be identified. Okay. So this is the development. Next comes the part, figure 3, this part, that is part A, part B again. Part A, part B. So part A, same procedure you have to follow. So again I have divided, I will be dividing this into n equal parts. Then project it. Then before that you extend this. You will get V. You know how to draw this. Simply rectangle. So this one, rectangle, if you fold it, you will get cylinder. But I have to worry about this. Now you take these points as reference. Now this is very important. Take these points as reference and join them because it is truncated to do it. So let me draw the calculate theta. Okay, 80, and this is L, and this is L1, and here you get all the true lengths. Project up to this and get these points. So first let me draw the frustum of cone, calculate theta, you get 161, same dimensions are there. Then take this distance and mark. So here you have to divide this into n equal parts. Okay, you know how to do that. In computer it is array. Give the angle and then keep the array. Then let me name this 1, 2, 3, 4, 5, 6, 8, 1. This is L1. This is L. Now take these distances. Starting from, if you want to rename it, A, B, C, D. This is A, B, C, D, E, F, G, H. Okay, 8 points. Then take one by one. Again you can draw arcs. See, here the first point is 1. You can say this is 1, this is 2, 3, 4, 5, 6, 7, 8, 1. The point it is from this one, 5th point is touching this section plane, and here for 1 you take this distance from V, okay, this point and this point, or draw full arc. Second and 8, this point. Then third point, 3 and 7, C and G, then D and F. Okay. So you will get the profile like this. It all depends on the angle. The 5th point is the touching point. Then draw this. So all depends on the angle. Now you see this, I have drawn for a particular angle, not necessarily 15 degrees, particular angle. Say I can, in general I can say theta. Okay, so here is theta value varies. Assume that it is 15 or 20. Now this part is this one, and total development is this. Then the profile you got is this. This is A, B, C, D. E is exactly coinciding with this. F, B, H, again A is the one. If you fold it, you will get like this. This is the truncation. So once you fold that, cut, they remove the unwanted portion and then keep it, you will get like this. Now the figure 3, okay, Figure 3 is this. Then you have the same thing truncated is this. Let me have a different complex. This one. Truncation is there. Okay. Next comes this one. The one which is having the frustum of cone again. Tapering. Okay. Tapering type. Then again truncation with the tapered one. Okay, so this is what the funnels. So same thing I can explain in computer one by one. So this combination may be anything. Bottom part B may be any of these four. This is one without truncation cylinder, and this is with truncation cylinder. Then the third one, the narrow tapering, that is frustum of cone again, and the frustum of cone again it is truncated at the bottom. So these four combinations. Now totally we have 8 funnels discussed. Okay, so this is what the solution of the funnels, and we will discuss the same one by one in computer. Let us take the funnels to discuss in this session. I have discussed this in detail, how exactly we can draw the development of the part A, part B. Okay, this is a simple funnel having the top portion, frustum of cone, and bottom is the just cylinder. Okay, so you know how to draw the development of the cylinder. Parallel method, you will get rectangle, that's all. So the height of the development is height of the cylinder, that is 75 in this case, and the perimeter is pi d or 2 pi r, that you know. Here this is frustum of cone. Let us see how to draw. That also we have done. Now let us see how to draw it. This is the fundamental problem which we have discussed in detail in the previous sessions. Draw the development of the lateral surface of the frustum of a cone, 50 mm base dia and 20 mm top face. So whenever you get this type, what you do is you extend this and get the imaginary apex, and then take total length, that is the generator. This is imaginary generator that is to be removed for the required solid. Now after drawing, after getting theta value, it's around 138 degrees. After drawing the complete development, you draw with L1, that is 27.08 in this case, draw an arc to complete this sector. Then this one will be the development required for this particular frustum of cone. So here for both the figures we have the frustum of cone. Here truncated cylinder, this is regular cylinder. For this we have to follow a procedure. You have to divide this into unequal parts and do it. So, and at the same time, let me give some more brief procedures which you have to adapt to draw the development for the truncated cylinder. We have completed this problem during previous sessions. Whenever there is a truncation with a particular angle, an auxiliary inclined plane cuts the solid with the inclination of 45 and passing through this point, the right extreme point. So you have to divide this into unequal parts and then get the imaginary generators. Wherever that intersects, you have to process. Then this is pi d, and divide this into unequal parts with the array, rectangular array, or using offset, that can be done. Now either you get this type or this type. That again depends on from where you start, what type of inclination you have. Okay, if the inclination is this side leaning left downwards, you get this. If that leans right downwards, you get like this. All depends on the starting point. Even with this, you will get the same thing if you start from this point. Okay, that you know. Now, if it is the truncated cone, frustum of cone is easy. Truncated cone, how to do it? Again, you have to divide it into number of parts and then project onto the base. Get the imaginary, wherever it intersects, you get the corresponding true lengths. After getting true lengths, you know how to draw the development. So you take on the respective generators, cutting points here, intersection points. Either you get this pattern, or the one more pattern is if you start from this point or the section plane is other way around, okay, you will get like this. This is like a necklace. So it's the identification of those points is very easy, either by drawing arcs or simply cut arcs on the respective generators. Okay. So with this basic information, we can start working one by one. See, this is a simple funnel. This is part A, part B. As I explained, if you calculate theta for this part A, you will get around 161 degrees. So draw the arc with 161 degrees reference, and the L1, L equal to the length of the imaginary generator equal to 89.44. This is 89.4, and the L1 is 32.92. Whatever you get, you do accordingly. This is a very simple procedure to draw the development of the frustum of cone that we already discussed. Then again, as I told you earlier, this is just a rectangle. Sometimes it is square. When 2 pi r equal to height, then that becomes square. That's very rare occasion. You get in general rectangle, pi d, and this is height. So this is the answer for the figure given here, part A, part B. Next, when it is truncated, it is inclined at some angle, bottom portion, then what exactly the procedure? So you know, the same rectangle is divided into 8 equal parts, and then the projected, this is the truncation of given angle. This is 60 or this is 30. Either way they will give, or sometimes they will give with respect to the axis. Okay, then you must be very careful in selecting the section plane. After taking selection of section plane, and you choose the section points and then project onto the respective generators. You can name 1, 2, 3, 4, and then corresponding points is A, B, C, D. Otherwise, you can do as such. No, there is no need to name all this. Just you mark, but better to name for clarity. Okay, if space is available and this is eligibly, you can have. Now, the part A is as usual, same thing, and part B is truncated cylinder. Then you dark it again. So this is how you dark this portion. Development of part B. This is development of part A. You can just mention. That's all. So this is how you complete the funnels type 1, type 2, without truncation, with truncation, especially for the cylinder. Now, the next part is the another two types is again another frustum of cone with smaller diameter, and this one also. Okay, this is again frustum of cone, this is also frustum of cone. Same procedure is to be followed, but theta has to be calculated carefully. Now, what I did, I projected this, okay, up to this point. Both lines must coincide with the axis. Now, same thing you have to do here, that we know how to do it. Okay, so same procedure you have to follow. Now, see, here is the frustum of cone, is another frustum of cone. Theta 1 is 161 degrees, theta 2 is 45 degrees, around 45 degrees. Now, what about this L1 of this is 60.47, with 60.47 as the radius draw arc for this particular sector. Again, this is the one which is at the top, part A, as usual you have. Suppose that you have again truncation for this. Assume that I take section plane from this particular point, 15 degrees or 30 degree, whatever. So next you have the truncation. It is around 45 degrees. Yes, I have taken 45 degrees from it. Is the section plane passing through the right bottom point of the frustum of cone. So now you draw this. Otherwise, this figure will be given to you. Accordingly, you have to draw. Now again extend it. Same procedure you have to follow. Now you get the points on the respective generators. You see, this part is same. Okay, no change. And this part is, you have to divide that into unequal parts. A, B, C, D, A. Again 1, 2, 3, 4 I have given. See, this one is I have given A, B, C, D, F, G, H. Again this is 1, 2, 3, 4. Then project onto the generator. Without doing this, you never get marks, and also that is the you never get the object whatever you are anticipating. So that is very important. You get something else. So what I did, I got generators because 3 and 7 on same distance on E, G and C. Similarly, B and H are having same distance. and then C and G, D and F are having same distance, I have drawn arc. Otherwise, you can draw arcs and stop there itself. So better you have this one, you will get some clarity. Then you join them clearly. See, you get like this. That's what I did. Now, after doing this, you try to dark this portion. Okay, completely. This one is same. Okay, there is frustum of cone only. This is the final development of A, the development of B. So the thing is, suppose that you have truncation here also. The top frustum of cone is also having some truncation either this way or from this left side point, right side extreme point. Both we can have. So see, this is the one of the sample there here. We have truncation for the cylinder and the truncation for the frustum of cone also. This I have taken a sample of this. You can choose any of these combinations. You know what to do for these type of things. All these four. Cylinder without truncation, with truncation. Then frustum of cone with truncation and without truncation. That can be done. So here you project it and get this value. After getting this, try to divide that into n equal parts and name it accordingly. Then you calculate theta and again you generate this particular development easy. Calculate pi d and then divide that into 4 equal parts. Then project it. At the same time, this one, divide that into number of equal parts and identify the respective lengths of the generators. This one is common. You take this and draw. That's all. This is L1. Okay, L1. This is L. So then you identify the points as in the arc method. Next, and also this one parallel method you complete. Then dark all this. Dark this one. This is the profile and this is the profile here you get. Next, dark the portion. See, if you dark it, you will get like this. And that depends on the angle. Okay, so I'm going to take a little more in the actual model and also for explanation. Here, this is the inclination, it's very small, so that's why you got very steep and also very smooth curve here. Now here, this is the truncated cylinder. This is the profile. This is very familiar to you now. Procedure is very easy. This also easier. When you take true length, then you will get correct answer. If you take direct length, then it's wrong. So definitely the all cylinders, cone with truncation, you must be very careful. You must take true length and do it. So you can also try the other combinations, as I told you, with truncation, without truncation, the cone. I have explained these things earlier. So now any type of any combination of these funnels. I have discussed 8 funnels. You can have some more preferences and also choice. Instead of having inclination this side, you can have other way around and complete. So this is how you can draw development of funnels. Now in the coming session, we will discuss the development of trace, this industrial use or the oil mills they use, and also there are many applications, especially funnels. You can see that in petrol bunks and oil stores and even industries they use for different purposes.